Welcome all. In this lecture, we will discuss about analysis of system using Laplace transform. So let us discuss how to find the response of a system using Laplace transform. So consider the differential equation of a system as a1 dq by dt cube of y of t plus a2 d square by dt square of y of t plus a3 into d by dt of y of t plus a4 into y of t equal to x of t, where x of t is the input signal and y of t is the output signal. So by giving a x of t, any x of t like u of t, step signal or anything, we can find the y of t by solving this differential equation. Response of the system, y of t is the response for a given input signal x of t. So for solving this, we can apply Laplace transform. So taking Laplace transform on both sides, we can take the Laplace transform of differential equation as from this equation. This is the equation for finding Laplace transform of nth order differential. So using this, we can find the Laplace of d by dt of y of t as s y of s minus y of 0, where y of s is the Laplace of y of t and y of 0 is the initial value condition. Similarly, for Laplace of d square by dt square of y of t, so y of 0 and y dash of 0 are the initial conditions, and for third order differentiation as this equation. So substituting this here, we can take the Laplace as for d cube by dt cube of y of t as s cube y of s minus s square y of 0 minus s y dash of 0 minus y double dash of 0 plus a2 into differential of second order differentiation s square y of s minus s y of 0 minus y dash of 0 plus a3 into d by dt y of t, Laplace of it is s y of s minus y of 0 plus a4, Laplace of y of t is y of s, and x of t, the Laplace of x of t will be x of s. We have to substitute here the given input signal, and x of s will be the output of Laplace of that input signal, x of t. Then we can rearrange this and we can find y of s from this equation. Then in order to find the response y of t, we can take the inverse Laplace transform y of t, which is equal to L inverse of y of s. There will be an expression in terms of function of s, y of s, and taking the inverse of that, we can find the y of t. For clear understanding, we can take the example. Determine the response of the system if unit step input is applied at t equal to 0, given initial conditions as y of 0 equal to minus 2 and d by dt of y of 0 is equal to 0. So here the given x of t as input signal is unit step input, means x of t is equal to unit step u of t. Then again we can say that the initial conditions are given y of 0 and d by dt of y of 0, that is y dash of 0. So we can apply Laplace transform. So taking Laplace transform on both sides, here x of t is u of t, then we have to take the Laplace on both sides. So Laplace of d by dt of y of t is this one, and d square by dt square of y of t is this one. So we can substitute here. This become s square y of s minus s into y of 0 minus y dash of 0, 7 into s y of s minus y of 0 plus 12 into y of Laplace of y of t is y of s, and Laplace of u of t is 1, then it is 1 by s. Okay. Then we can substitute the initial conditions. Y of 0 is minus 2 and y dash of 0 is 0. So substituting that, we will get s square y of s, here minus 2, here y dash of 0 is 0, and here y of 0 is minus 2, and the terms. Okay. Then we can find y of s from this equation. For that, we can take y of s common. So it becomes s square plus 7s plus 12 into y of s plus this 2s and this 14 here, s7 into 2, 14. Then we can write take this 2s plus 14 this side, so 1 minus s minus 2s minus 14. Then we can multiply this s by this, so it to minus 2s square minus 14s plus 1 by s. Then we can write y of s as we can take this term into denominator here. So now we can find y of t by taking inverse of this y of s. So again y of s we can factorize this s square plus 7s plus 12, so it becomes s plus 3 into s plus 4. Then we can take the partial fraction, so let this whole term equal to a by s plus a by s plus 3 plus c by s plus 4. Then become minus 2s square plus 14s minus plus 1 equal to a into s plus 3 into s plus 4 plus bs into s plus 4 plus cs into s plus 3. Then we can find a by putting s equal to 0, b by putting s equal to minus 3, c by putting s equal to minus 4. So we got a b c. So we can, instead of this term we can write in terms of a b c, like y of s equal to 1 by 12 by s plus minus 25 by 3 by s plus 3 plus 25 by 4 into s plus 4. Then we can take the inverse directly. So taking inverse on both sides, this become y of s become y of t, and inverse of 1 by s, 1 by 12 is constant, in Laplace inverse of 1 by s is u of t, and 1 by s plus 3 is e raised to minus 3t, 1 by s plus 4 is e raised to minus 4t u of t. And we can take u of t common, so it become y of t equal to 1 by 12 minus 25 by 3 e raised to minus 3t plus 25 by 4 e raised to minus 4t into u of t. So this is the method how we can find the response of system using Laplace transform. So with this we can wind up the session. Thank you.